Hey, hope you're having a good day, and I hope you learn some logic before the day is out. Let's see what we can do to facilitate that. I have two proofs here. I already have the structure set up. These rules are going to do a little bit with each of the 5 rules so far. At this point, the rules are cumulative, and so we have from the last section modus ponens, modus tollens, and now we have conjunction, simplification, and addition to add to the mix. We'll keep going here as we proceed. Okay, on the left, and by the way, perhaps you want to give it a shot straight away before seeing how I go through this, see what you can do. Or maybe you want to watch me do it and then go and give a shot to, as you should in any case, all the exercises or as many as you can in the book. All right. We have 3 premises here, not A, if B then Z. If not A, then B and Z. To proceed here, what we want to do is first scan what we have. Keep in mind where you're going as well. There's sort of the working forward and working backward kind of thing that I talk about in the book, in addition to plenty else that you should take a look at and think about. From the working forward kind of thing, we see that in lines 1 and 3 we have a modus ponens. Line 3 is an if-then. Line 1 gives us the antecedent of that if-then. So we can say, by the modus ponens, the consequent of that if-then, which in this case is B and C. So I can start by saying B and C, modus ponens, lines 1 and 3. At this point, to proceed, we have to use one of our new rules. If you look at lines 2 and 4, there's something of a modus ponens, but it's not by the modus ponens rule, and it does depend on the details, in particular what the operator right here is. And so we formally go from 4 to 5 and say B. We have an AND claim. Whenever we have an AND claim, we can simplify it by the simplification rule. Simplification is an inference from one claim, so we have one line number in parentheses, and we have B. Once we do that, it, so to speak, sets up the modus ponens. Now we have, if you look, lines 2 and 5 of modus ponens, basic modus ponens, no extra operators or parentheses or complexity there. We can say Z by modus ponens, lines 2 and 5. Now, and again, you maybe wanted to do this before. You got to think about what you're trying to prove. We're trying to prove Z or E. Since we have Z, we know that Z or E has got to be true, because for an OR to be true, only one of the 2 parts has to be true. And we can simply take Z and make it Z or E by the addition rule. Wouldn't work for other operators, but for OR, because of the nature of OR, it works. Okay, second proof. This one's actually probably slightly easier. We have if A then X, if not A then not B, not X. We're trying to get B and not X. Let me talk it out going backwards. Conclusion not B and not X. Look at what we have then. We already have not X. So if we can prove not B, then we can use our conjunction rule to get not B and not X. Of course, that takes familiarity with the rules. That's what you're trying to develop, but that's how we're going to put this thing together. All right, let's see it. To begin, lines 1 and 3, we can put together to get not A. That's the modus tollens rule. Basic instance of modus tollens, line 1 is our if-then, line 3 is negation of the consequent. That puts us in the position to do a modus ponens inference between lines 2 and 4. Line 2 is an if-then. Line 4 gives us the antecedent of that if-then. So we get the consequent, not B. Put it another way, if we have if not A, then not B, and we have not A, we get not B. The name of that type of inference is modus ponens. Lines 2 and 4. And now, to finish it up, we've proven not B. We had not X. We just put them together as not B and not X. And when we combine two rules, premises, lines, claims that we have as true, that's called conjunction. And that's a conjunction of lines 3 and 5. There you go.